Hello and welcome to TecQuipment's webinar and VDAS, and we'll also be covering the thin cylinder apparatus during this session as well. My name is Dion Knowles and I'm the marketing manager at TecQuipment, and today I'm also joined by Dave Giddings.
Hi there.
A little bit of background because I always have this slight battle with my mouse as we get rid of that.
There we go. It's gone. It's gone.
Now we've resolved all of our technical issues, and I've had a fair few of those this morning.
We have had a challenge this morning.
We have, and you've been busy setting up for this VDAS demonstration, which is why we didn't see you in the live Q&A yesterday.
No, I went to the factory, picked up some kit, brought it back to my mini lab that I have in a small corner of Nottingham.
Wonderful. Well, we look forward to seeing your lab setup.
Yeah, I quite like this actually. I could get used to this.
Yeah, brilliant. Well, I've got kind of my mini engineering science lab in my house.
Oh, okay. So maybe I can get a gas turbine.
Oh, yes. I'd like a wind tunnel.
Oh, well, just stick to your hairdryer, Dion. You know.
Oh, that's not good enough. Anyway, first up, I want to do a few shout outs for people. We've already got quite a few people joining us live watching this. We've got Charles Costa. Charles, brilliant to see you. Where are you watching us from, Charles? We've also got Bruno joining us. We've got Silvio.
Hi, Bruno.
From Brazil. Silvio, I hope you're okay there.
Hi, Brazil.
Great to see you with us today. Do let us know if you are watching this live. Put a comment in that chat box and let us know where you're watching from and perhaps what the weather's like today. In the UK, we've got a wonderful heat wave at the moment. It's sweltering hot. How's your temperature in there, Dave? You're sweating?
It's like me, cool.
Cool, wonderful.
Well, no, I've got a fan next to me, so I'm in good shape. The sun's on the other side of the house, so I'm pretty good here actually.
Oh, that's good to hear.
Yeah.
I'm not too bad actually either. As you're saying, he's gone to the other side of the house now.
Yeah.
It's and Charles is in sunny Essex. Great to see you there, Charles. Essex. We've also got Jezzy from South Wales. Brilliant to see you.
Wonderful.
Great mountain biking in South Wales, I should add.
And North Wales.
And North Wales. I haven't been mountain biking in North Wales, but I've been mountain biking a lot in South Wales.
Splendid. Good.
Anyway, right. So let's talk about what we're going to be covering today. We're going to be talking about VDAS. That is the versatile data acquisition from system from TecQuipment. This is our proprietary system, and we're going to be talking about how this can be used with various different teaching apparatus. But Dave has in particular got a thin cylinder apparatus. So he's going to be showing data from that. He's got it in his own home office there. So
I have.
And we'll also be talking about how this can be used in a distance learning scenario or a remote learning scenario to help deliver practical based learning. Now, obviously, there are limitations there in terms of getting hands-on, but there's still possibilities. There are still ways that you can make that learning experience more meaningful, deliver more empathy that we were talking about in the Q&A yesterday. We've also got John Foster from Cumbria. How's the weather up in Cumbria, John? Do let us know. Beautiful part of the country as well. So, Dave, before I'm going to hand over to you, I'll let you finish your pickled egg and whatever else, pickled onions or whatever else you might.
It's all gone, all gone.
And before I get on with resuming with kneading my pizza dough for dinner tonight, I'm going to tell you a bit more about TecQuipment for those who don't know that much about us. I'll make this brief because some know quite a lot. We have a worldwide presence. We design and manufacture everything all in one roof in Long Eaton in the United Kingdom, but we have customers in more than 100 different countries in more than 1,200 different organizations. So a very wide reach there. We've been established for over 63 years. If you want to know more about that story, then you can have a look at our website. And we, as I said, we design and manufacture everything all under this one roof. At the moment, we've got people in production with the social distancing, with all the PPE in place. Those who are not absolutely essential, like for production, like Dave and myself, are working from home, and this is where we are doing our live streams from, me in Derbyshire and Dave in Nottinghamshire. So a bit about us as a principles of company. As a company, we're all about creating the best products for practical teaching of engineering principles, whether that's at A-level level, whether it's at HND level, whether it's at degree level, whether it's even in some vocational courses as well. And it's about real life understandings that match the skills required for the market, the employability market today and tomorrow. And it's really being connected to that. We're about more than just products. We want to, we see ourselves as playing a role, a holistic role in the teaching process. And we do this in a couple of different ways at the moment. Global communities on LinkedIn and Facebook and YouTube, through the practical teaching and engineering education communities, and engagement activities like the student competitions, which I will come on to talk about more shortly. Stay with me. We are getting to VDAS very soon. Before we do that, I want to tell you a bit more about how we design our products. One of the most critical things is that it's about fostering curiosity and sparking passion. Passion so that students really embrace the concepts of engineering. We're taking it up a level from that theory, from the pen and paper, and getting them involved, getting them hands-on. And it's not just that. We want our equipment. We're talking about sustainability yesterday with Ram Shankar in our Q&A. And that's really important to us in terms of having products that will stand the test of time, that will go on year on year on year. We do a 5-year warranty, but it goes much beyond that. We've got equipment that's still in use back into the 1960s. That was before I was born, quite a lot before I was born, for that matter. We're also all about how, when we're enhancing products, how can we improve things so that it performs faster, but without compromising learning outcomes. So making it more effective experimentation. And VDAS is a really, really important part of that. Sometimes you've got experiments that will go on over 3 days. And I think that might be the creep testing machine. And you simply can't sit there and take the data all that time and all the different data points. VDAS is very instrumental for enabling that data and analysis to occur. As a principal, as an organisation, we're about simplifying teaching as well, integrating functionality that matches your syllabus. And people have different syllabuses, so we have to sometimes agree compromises, adapt the way we do things. But we also make that easy by providing supportive instructional and theoretical material in our manuals that the academics use, that the students can use, that's for maintenance as well, all in there to make your life as easy as possible. Then, of course, we've got people like Dave and the rest of the customer care team. They're always on hand, however long you've had a piece of equipment for, to support you, to provide guidance on how you might maintain something, overcome a problem, etc., and provides spare parts where required. So, Dave, pickled egg hopefully is complete.
Yes, indeed.
I can get on and knead my pizza dough.
You need.
You can tell us a bit more about VDAS and a thin cylinder.
Okay, so let's have a look at that opening slide. So we are going to talk, well, originally we were going to just dedicate this entirely to VDAS, but with my way of thinking, I thought it'd be much more valuable to have a piece of kit actually hooked up to VDAS. So this has now evolved from being just a VDAS presentation or show to a product related discussion as well. Now I know we did materials testing some weeks ago, but this is going to be actually a 50-50 talk about VDAS and a piece of equipment. We've learned, or Dion and I have learned, that the viewers like to hear a little bit more technical information about the product. So that's what we're going to do. And by having a piece of equipment, we can make it a little bit more exciting. So behind me, which you'll see soon, I've got a SM 1007 thin cylinder. So allow me to briefly talk about this firstly. Basically, all engineers need to know how to predict the effects of stress on shapes, on common shapes, okay? They can use this information to decide the right type of thickness and the right type of materials for their own designs, okay? Now, the thin cylinder, or our thin cylinder, shows students the strains in the surface of a thin-walled cylinder when it is under stress from an internal pressure, okay? So where's that in the real world? Well, those applications include pressure pipes, aircraft fuselage, and compressed gas cylinders. So it's all real, okay? So with the thin cylinder, the students will learn about strain gauges. They will learn about Young's modulus and also Poisson's ratio. I'll come on to those definitions in the next few slides. But what's the difference between a thick cylinder and a thin cylinder, okay? So basically, cylinders in the real world are divided into two groups, okay? You have a thick cylinder, which TecQuipment also offers, and you have a thin cylinder. A thin cylinder has a diameter to thickness ratio of more than 20, okay? Now, a thick cylinder has a diameter to thickness ratio of less than 20. Now, our SM1007 has a ratio of about between 26 and 32, okay? So there we've got a good picture of the SM1007 there. So while we're doing that, I'm just going to be pretty smart here, and I'm going to actually turn around in my lab, and I hope that you can see there that I have a full configuration of a thin cylinder, live displays showing the connectivity and the major components there. So the reason I've say again, sorry.
We can see that, Dave, with your lovely floral curtain in the background.
I will go into more detail about the major components, but we've got a cylinder there. We have a board on gauge there measuring the internal pressure. We have a frame. If I go to a plan view, we have a steel frame on the outside. On the front, we have digital displays of the strain. And then we go to the hub, which I'll talk about later, the VDAS hub, and then an on-screen display of all the major components. So I'm just reverting back to my normal position there. So this cylinder, this thin cylinder is actually a thin-walled aluminium alloy cylinder, okay? Now inside each end of the cylinder is a piston. Now that steel box that I just showed you, it contains electronic equipment that works with the strain gauge display, and it links to the TecQuipment system, okay? Now, like I said, fitted to the surface of that cylinder, there is a set of electrical strain gauges, and on the front there is a display showing the strain measured by each of the gauge. So to apply internal pressure to that cylinder, the students use a hydraulic ram pump. Now you can see the handle of that ram pump and the black cylinder underneath it. And that hand pump actually forces, or it's used to force oil into the cylinder. And that board on gauge, which you can see there at the top, that measures the pressure of the oil in the cylinder. Now there's also an electronic sensor or pressure transducer, and that connects to our TecQuipment VDAS. Later on in this show, we're actually going to display some data that I took just a few minutes ago, and I've shared it with Dion, okay?
Brilliant. Now, Dave, I just want to give a quick shout out to Robert Seaton, John Foster, Sam Kumar. Apologies to Robert quickly, because we said we were going to cover the thick cylinder demonstration in this, but it's actually a thin cylinder.
This is a thin cylinder.
And that was my bad.
Don't worry.
I hold my hands up to Robert there. I'm hoping that Robert can still gain a lot of insight from looking at the thin cylinder today, Dave, would he?
Yeah.
Brilliant.
Yes. There are similarities, but so I'll carry on then. So basically, with this experiment, we have two conditions. We have what's called open and closed ends. Now you see that hand wheel on the right-hand side. This sets the cylinder to either open or closed, okay? So if you go to the next slide, we should see a diagram. Now that is a diagram there, okay? And that's open ends, okay? So when the user screws in that hand wheel, it clamps the free moving pistons in the cylinder, and that frame actually takes that axial or longitudinal stress and not the cylinder wall. So that in real life would simulate the cylinder having no ends, and that's called open ends, okay? Now the next slide is closed ends, okay? So you can see a difference. So when the user actually unscrews that black hand wheel or unwinds it, the piston actually pushes against the caps in the cylinder and it becomes closed ends. So in this situation, the cylinder wall takes all that axial or longitudinal stress. So that's the difference between open and closed ends, okay? The strain gauges, they are sensors that measure the strains in the walls of that thin cylinder. Now we know that strain gauges are electrical sensors, okay? They're only a few microns thick, and they are bonded onto the cylinder, okay? Now there are actually 6 different gauges on the cylinder. No, 6 different positioned gauges on the cylinder, and they are deliberately bonded at various angles to allow a study of how the strain varies at different angles on the axis. So numbers 1 and 6, they are called hoop strains, okay? I'll explain the definitions in a minute. Strain gauge number 2 is actually longitudinal, so it's going left to right. Oh, thanks, Dion, that's better. Strain gauge 3 is at an angle of 30 degrees. Strain gauge 4 is at an angle of 45 degrees, and strain gauge 5 is an angle of 60 degrees. So the definitions I said I'd mention. The longitudinal stress is the stress along the cylinder length, okay? So left to right. The hoop, or numbers 1 and 6, they are the actual stresses around the diameter of the cylinder, okay? And then we have a radial stress, which is the strain gauges at different angles. So the strain gauge display shows the readings of each strain. The users can scroll up and down accordingly. Just a little bit of, I know we've covered this in our materials webinar before, but I'll go through the definitions again. What is stress? Well, stress is the applied force to a material over a known area, a known value, and it's found by an equation, okay? Strain, another key word, this is the change in length or distortion of a material over its original length, okay? Young's modulus, this is another definition, it is a ratio of the stress divided by the strain. Thomas Young, an English physicist, discovered this, and he also therefore discovered the definition of Young's modulus, okay? And then finally, we have Poisson's ratio, okay? Simeon Poisson discovered this, and he found that the ratio of the transverse strain in a material at right angles to the applied stress against the longitudinal strain. So it's another ratio, okay? So there's a definition of the objectives, if you like, of this experiment and the makeup of the strain gauges. So if we go to the next page, we might see VDAS screen.
Some really useful tips. I like the fact that people are getting in there and giving some comments here. John Foster highlights that the thin cylinder is a better start for students because the stress is two-dimensional. So well adapted for teaching complex stress through more circular strain and stress. Sam also adds that rosettes are essential in stress analysis.
Yes. Yeah, we do use rosettes in some instances, but equally when we're using quarter bridge, half bridge, three-quarter bridge, we often introduce dummy gauges as well. But rosettes make the application sometimes easier.
Okay. Right. So thank you very much for your input, everybody.
Okay, so now we've spoken a little bit about the SM1007. I'm going to talk a little bit more about VDAS. Sometimes manually recording data from various experiments can be quite tricky. It can be difficult, okay? It can take time, it can be repetitive, and like Dion said, some experiments require the user to take thousands of readings, like, for example, the rotating fatigue machine, where if we're, for example, spinning a piece of mild steel with no load at minimal speed, this could take days and thousands of cycles to break. So this is where VDAS does come into itself. It is often necessary to adjust controls and instruments while taking readings. So this reduces the amount of people required in front of equipment, okay? And we make mistakes. I make mistakes. Dion makes mistakes. And this can lead to errors in our calculations, either mistakes when writing down the data, entering into a spreadsheet or a computer, and it can give faulty results, okay?
I think, Dave, it's a really good point how you said there. I'm just going to pull you out this out.
Sure.
You said it requires less people. At a time like now, when we're talking about how can we run experiments and do remote learning, maybe some people are doing videos running experiments, it would mean that maybe only one person would be required to do an experiment. You could set it up.
Absolutely. I mean, I'm not saying that's the case on all of the equipment. I mean, like the wind tunnels is a little bit more complex, but I set up here at the back of me a thin cylinder with VDAS. It took about an hour to get all the cables and the power supply around the room. But this morning I've taken a snapshot of data, which we're going to look at in a few moments. Okay, I've built a graph in the space of minutes. I've actually sent it to Dion, okay, or to yourself, Dion. So if I was a professor remotely in a lab and I've got 50 potentially idle students at home, I could pigeonhole their inboxes with a set of data, and I could say, right, there you go, do the manipulation that you're going to see in the next 10 minutes or so. That's the power of VDAS, and it might be even more relevant in this climate now.
Great. So we've all got all different approaches to VDAS, haven't we? We've got the bench mounted, the frame mounted, and
well, I'll come on to that now. So there are actually a number of types of VDAS, okay? We have VDAS B on the left, and I'll explain in more detail in a moment. We have bench mounted, we have frame mounted, and we have on board. So what's the difference? Well, VDAS B, this is for bench mounted equipment, okay? It's identical to the VDAS F, but it's compact, it's in a small metal box, and it's ideal for use on a desk or bench top, okay? The VDAS F, which we might see next. Now this is a frame mounted F for frame, okay? It's the same functionality as the B. It's identical to VDAS B, except it is housed in a rugged rectangular metal box, and it fits onto the instrument rails and frames on many of our equipments, whether it's engine TD200, MFP, H47, H83, and so on and so on. So that's the difference, okay? And then finally, we have VDAS on board, which I think we have a picture there. So this is integrated. It's actually inside and built in to our experience. And these products then can be connected directly to a suitable PC. So this is the difference between the three, okay? Let me just take a break there.
Brilliant.
Okay, so the next slide, we have perhaps a VDAS screen.
Right, let's go over to VDAS. Here we are.
Let's have a look.
Now, I should stress that this is super easy. I had to download the latest version of VDAS this morning,
Yeah.
and Dave sent me a DAT file, which I have
Brilliant.
then simply opened it by going into File and Open, and then navigated to where that DAT file was. And
Yeah.
here you go, Dave.
Yeah, so if you could just, yeah, that's perfect. So with the software, this displays real-time data numerically, either as digital or analog traces, meters. We are able to log data for printing and viewing later. We can even export data. Now I'm going to put you on the spot now, Dion. Okay. Now I didn't warn you earlier. Can you see that little Excel icon in the toolbar? I would like you to click that.
Right. Okay. It's thinking. It's really the hamster needs to run faster. Here we go. So I could save that.
Yeah, I want you to save that to your desktop.
So it's my desktop, right? Okay.
And then with a bit of luck, then we should see an Excel spreadsheet actually open up.
Oh, there we go.
Wait for it. Wow, look at that.
We really had not rehearsed this. I had no idea it was coming.
I swear this is
I haven't
not
done
rehearsed.
this before.
That's your first time you've ever exported data to Excel, okay? So you can actually minimize that now, because we can go back to the VDAS screen.
Okay, there you go.
I can sense your achievement there, Dion.
Yeah, I had a bit of a panic there as well, thinking, what if it doesn't work? Not working. That's really cool.
That's how easy it is. So we can use the data to create. We can print charts. We can do tables, and the beauty of it is the ability now to save that, either the data file or the Excel spreadsheet that you've just created, and we can export it, we can save it, we can broadcast it around the world to students who can then spend hours, days following the instructions in the manual and produce the charts that we're going to see in the next few minutes, okay? So if we go to the next slide, we might see then a little bit about the data inputs. Yeah. So on the VDAS hubs, or on the B and the F, there are a number of sockets and connections there, and these are basically known as digital inputs. So the analog signals from our VDAS compatible products connect to one or both of those analog inputs, and then you connect the USB cable which is supplied to your computer. Okay, so that's it is so intuitive and easy to use. So if we have a look at the next slide, and I think that might be,
I think we have the data. Do you want to see the data, Dave?
Yes, go on then. Now this is actual data, okay, that I have produced in my mini lab this morning, and it's in accordance with the first 3 experiments in the manual, okay? So at the top, you can just see a definition of the strain gauges. That top colored box there, it tells me whether the strain gauges are, whether they are hoop, longitudinal, axes, or again, hoop. That's the definition, okay? If we go to the next table, there is basically a row of data. Now I have built these spreadsheets, I have built these graphs in a matter of minutes, okay? Because the first experiment is to look at how linear these strain gauges are. We are looking at linearity, all right? So we should be able to plot force, the amount of pressure in the cylinder, against the actual strain gauge readings, okay? Now, we can see now that there is a linear relationship. As you can see on the first graph down the page, Dion, if you could scroll down, we can see that all those strain gauges are linear. And that proves a couple of things. It proves that the strain gauges are working, they're bonded, and they are sending they are sending signals back. So we have actually drawn a straight line through the points for each of the gauge, and that is actually experiment number 1. Okay, experiment 2, we actually then use some magic in the software in VDAS, and we prove that there is a linear relationship between stress and strain. Okay, so the linearity of these results prove that the strain gauges are good on the thin cylinder. But if we calculate the gradient, which I've done there, of that graph, I can see a value of 68. Okay, it's probably too small a writing on the actual graph, but it says 68. That is actually the Young's modulus of the material. So I've taken the results of hoops 1 and 6, and I've plotted on the vertical axis the stress, and on the other axis the hoop strain, and I've got that from VDAS. That is from VDAS, and I've just taken that data and I put it into a very simple graph. But the achievement that we have performed is we have actually calculated Young's modulus. Without VDAS, it would have been quite a straightforward procedure, but having it automatically exported into Excel, like what Dion just did a few minutes ago, I've actually been able to produce that and share it with Dion just before we became live. That's the power of VDAS. Okay, and then finally, if you scroll down, we can actually look at the relationship of the longitudinal against the hoop strain. Okay, now from the gradient of that graph, we can actually show the Poisson's ratio for the cylinder material. Now, I gave you the definition of Poisson's ratio earlier. On that graph, it's quite small writing, but I think it says 0.328, I think. Yeah.
Yes, correct. Yeah, you
it's
can also
very,
see it in red here.
It's very small. It's very, very tiny writing. And in the manual, we announce in the manual that Poisson's ratio for that material is 0.33. So if I was to round up my values to 1 decimal place, then there we have 0.33, or 2 decimal places, exactly the same as what's in the manual. So in a matter of minutes, I've done the experiment, I've saved the data, I've exported it to Excel, I've constructed some graphs, and abracadabra, I have found the linearity of the strain gauges. I have shown Young's modulus with the gradient of the graph in that way, and then I've shown Poisson's ratio for the material of the cylinder, and that is the power of VDAS, Dion.
Fantastic.
Okay.
Now I'm going to speak momentarily about LabVIEW, because VDAS does have further functionality that you can export to VDAS data into LabVIEW virtual instrument as LabVIEW virtual instruments, and then you can further develop those that data within the LabVIEW environment itself. And there you can see a brief screenshot of that. Also, I want to stress how easy it is and how unlimited it is in terms of software. Dave's talked about hardware and we've been through the software, but this morning I needed to download the latest version, so I got hands-on on how you actually do the process. It's so easy. It's unlimited, so your students can download it. You simply go to the downloads area of the TecQuipment webpage, so it's techquipment.com/downloads. You look for the latest version of the download, which is 3.02, and you simply click on the download. You then save it into your file, and then you execute that installation. It really is very, very quick and easy. And this is the kind of entry GUI you get there. It allows you to access all of the TecQuipment products with VDAS.
Yeah.
You simply search it or scroll through that list, you click on it, and then you're getting to that screen that we saw a few moments ago that I'll show you very, very clearly here. Now, Dave, now I'm on this. How easy is it just to switch my experiment? So I'm on this strain gauge experiment now. If I wanted to go to a different piece of apparatus, what would I click on?
Well, the first thing you need to do is you need to unhook your data cables that are connecting the VDAS to your existing experiment. then you would need to move the hub or bring your experiment to the hub. Go to, I'm gonna test you again. If this is a live screen,
It is.
I would like you to go to options.
Yeah.
Select VDAS application, and then you scroll down to your chosen product.
I'm having a wind tunnel in my home office. There we go. One of those.
There you go.
We do things by halves. There we are. One wind tunnel.
Yeah, so you can see your pressure readings there, wind speed, etc. Now there are some extra buttons on the top of that dialog box there. You don't have to export to Excel. You can create and edit graphs within the VDAS environment, okay? And that's what the buttons you can see there. There are various instructions where you can actually add data rows. You can deliberately delete data sets if you have some nuisance readings. There is provision for doing a live display. So if you're looking at a creep specimen and you want to watch it overnight, for example, you can actually observe the graph building itself, okay, in a live environment. So you don't need to export to Excel. It's my chosen method because of because Excel is such a powerful program. Okay, once you are in the Excel environment, you can actually right click on a number of the descriptions. You can observe the formulas that the software has used, and you can even change the colors, and I think you can even change the language in some of the descriptions as well. So that's just another added benefit of the VDAS system. Oh, there you go. Yeah.
There we go. Communications. Okay.
Yeah, so
just some of the many options there. Display the chart window. There we are.
Yeah. So within 3 clicks, you are actually ready to record or connect data. And within 4 clicks of the mouse, you've actually got data. It's so simple, seamless, and user-friendly.
Marvelous. Well, it certainly is, because I've not practiced this before. So it's testament.
I'm testing you. I'm testing you today, Dion.
Really putting me under pressure, Dave.
Yeah.
Oh, brilliant. Right, so let's hop back over to the presentation now. We've pretty much covered all the VDAS and the thin cylinder details, but this is live. So this means that you can ask your questions in the chat box. If you're watching it on demand, put your questions in the comment box and we'll come back to you in time. But if you're watching it live, put your questions in the chat box and Dave will be able to give you the answers to those.
Hopefully.
Now, brilliant. Don't go though. This is not the end. We have more to talk about today. We're going to talk about remote learning support. Many people are looking at how can they achieve that at the moment. Dave's going to talk more about the rest of the ranges that we offer. So if you're not au fait with everything else that TecQuipment brings to the table, then stay on watching this webinar for the ranges overview. In a bit, I'm going to talk about student competitions. You might be interested in how you can engage students more through competitions and some of those online communities. And then we'll have a little bit more time at the end to cover any Q&As that we haven't answered throughout the course of this session. Keep your tips coming in as well. We like to add those too. So Dave, you can chillax a little bit.
Okay.
Get your Diet Coke out. I'm going to talk about remote learning support. Oh, Pepsi. Sorry, you're not a Coke man. You're a Pepsi man.
A Pepsi man.
Oh, right. Remote learning support. So at the moment, TecQuipment is in a full drive to see how can we support you during the COVID-19 crisis. You've got students that might be allowed back into the labs in small groups. You've got scenarios where they're simply not allowed in the labs, but academics are, or maybe you're an academic and your university is not even allowing you into your institution yet. And this could be very much of a changing landscape that we're all watching very closely. We're trying to serve you the best way we possibly can. That's why we're doing the webinars like we are doing today. We've got the online communities. Want to just bring your attention to these. We've got communities on LinkedIn, Facebook, and YouTube, you can get involved, you can share ideas, share thoughts, ask questions to the community. That's the practical teaching and engineering education communities. We've also got a resource area on our website, which is the remote-learning-support area. You can find a PDF guide in there with videos, general videos, not necessarily TecQuipment ones, ones that are freely available on YouTube that might show topics in detail that are really engaging out in the field, that relate to the various different engineering disciplines, whether it's understanding cavitation, for example, or whether it's a day in the life of a civil engineer, that kind of content. On the TecQuipment YouTube channel, we have a playlist that is dedicated to student experiment videos. We've got, I would say, 15 to 20 videos in there of students using the apparatus. These were actually students who entered the 2019 and 2020 TecQuipment student competition, where they had to perform an experiment, test a theory and do a video on it. So there's theory in there, there's practical experimentation. If you're looking for content, I'd have a check out and see what's in there. We've got turbines, we've got wind tunnels, we've got various fluid mechanic, thermo stuff all in there and more. As well as if you're looking at creating your own lab videos, you're thinking about how can you do this, we've got a very short video available on YouTube that gives you some top tips. We also had a Q&A a couple of weeks ago with a video editor and post-production specialist. He was talking about how you can use your phone and lots of other tips, video editing tips, for example, tools you might want to use. I would suggest you have a look at that. That was with Andrew Riches. So if you are looking at that option, do check it out. And we discussed the merits of doing live demonstrations versus doing pre-recorded content. And then every Wednesday up until the end of July, we are continuing these. We've got the live Q&A sessions. That's where we talk about all kinds of different topics, whether it might be how to cope in COVID-19 from a clinical psychologist, whether it might be hearing from some of the latest innovative universities. We had Teddy London talking about their project-based degrees that they're implementing, whether it's different educative learning approaches. We had Oliver Shaw from Trafford College last week, and he was talking about how they are delivering remote and distance learning at their college. They introduced students into their college 1.5 weeks ago, and he talks about the practical implementation of that. So if you're thinking about how can you achieve that at your university and college, I would encourage you to have a look at the on-demand version. So all of our Q&As are done live, like we're doing this webinar live today. But if you're watching this on demand, you can also watch the Q&As on demand. So the content sits on YouTube, ready for you to watch at the time that is convenient. We do these live Q&As every week at the same time. It's 1 o'clock on Instagram, 2 o'clock on YouTube. And we will also continue with these webinars throughout to the end of July at 1 o'clock on YouTube. Obviously, that's British Standard Time, so you need to convert it to your own time zones if you're somewhere else in the world like Brazil or New York. Easy way of doing that is clicking on the reminder bell. If you're logged into YouTube on your phone, for example, you click on the reminder bell and 30 minutes before you will get a notification to say that we are going live. You may well have joined us live as a result of that reminder bell jumping you into action today. So that's it from me talking about remote learning with support. I'm going to call up Dave to talk about the other ranges that we offer now, Dave.
Yeah, so let's go to something a little bit different.
Actually, Dave, before we go into the other ranges, I think we can just cover a question. John Foster says, the VDAS you're using appears to be a new addition. How do we upgrade?
Well, if you've got existing equipment and you're using an old version of VDAS, what we'd like to hear from you is exactly what equipment you have. Look at the serial number on the back. We can then go to our records and see how old the VDAS is, whether it's still using serial ports, for example, for communication. It would be really beneficial to know exactly what you have there, John, to be honest.
So Dave, can you not just download the latest version of the software? Is that not
Yes,
compatible with all previous
you
generations?
can the software,
Okay.
but I would strike a note of caution because I want to make sure that the hardware also is still compatible with the latest version of the software. So that's why I'd like to know about the hub. How old is the hub? There'll be a serial number on the back of it or underneath it, and then we can do some analysis and find out whether it is, you know, doable, whether what he has is future proof. Okay.
Could he do a test and download the latest version and just see if it works?
Yeah,
for example, maybe.
There wouldn't be any harm in doing that for sure.
Okay.
No harm.
So just to know how to download that, go to techquipment.com/download.
Yeah, downloads, yeah.
And that's the process I showed you earlier.
Yeah.
And you scroll back through the webinar later, and you can see it's just so simple to do.
Yeah, if John wants to leave his contact details, then we can certainly look into this offline.
All right, wonderful. Another question now. Tono Oliveras has asked us, is it possible to do a demonstration of some examples of structures with VDAS for another opportunity? But
yeah, with structures, we have similar software, as you know, DL,
yeah,
where we can use it for automatic data acquisition. You can use it also for virtual experiments. So if you buy the STR 2000, that gives you the glory of being able to work on 19 experiments virtually. But or you can use it just for automatic data acquisition.
yeah, but we can't do that today. We can't do the real live demonstration.
I could do it. I could do it next week.
Next week. Brilliant. All right. Okay. So Dave, do tell us more about the rest of the ranges that.
Okay. So we're looking at engineering science. So we've got here 18 modular experiments. These experiments are a fantastic introduction to engineering, into mechanical engineering and physics also. So these kits cover topics such as moments, we have friction, we have cams, we look at tensile, which we actually stretch specimens to destruction, and they all sit on a standard work panel, which is what you see on the top of the trolley there. Some of the experiments demand that you work it in portrait, which is what you can see there. Others, you might be asked to convert it to landscape. And that's a very simple task of rotating it.
I can tell you, even an 8-year-old can do it.
Yeah. Fluid mechanics next.
Let's go to fluid mechanics. Here you go.
I think that's next on the.
It is. So we've got
yeah. So this is an extremely extensive range of very high quality fluid mechanics teaching and lab equipment. Okay, we as a company were the first to offer a modular range of equipment for the fundamental studies of fluid mechanics. Okay, there are practical fluid experiments available for all fluid mechanics courses. We cover everything. What you can see there is one of our very large flumes that have become quite popular of late. Engines. We covered engines. Was it last week or the week before? I lose track of my mind now. But
I think it might have been last week, but I do lose track as well.
Oh my God. Oh dear me. Yeah, so engines topic, we cover internal combustion engines, covering diesel engines, petrol stroke gasoline engines, and also gas turbines are covered in this subject. So a wide range of equipment. Control engineering, this offers fundamental and advanced investigations into control principles using actual applications you would find in industry, and it looks at stability control of aircrafts, rockets and ships, etc. All the CE range includes our own dedicated CE 2000 software. This is actually free of charge, and it can also be used for simulated controlled experiments. That brings us on nicely to the process control, demonstrating fundamental and advanced studies into real-life processes like PID, DCS, and cascade control of pressure, flow, level, and temperature. Oh, electrical power. This is very, very different. This range provides an advanced teaching and training equipment for all elements of a power system. Okay, Dion, that will cover the areas of generation, transformation, transmission, distribution, utilization, and protection. That's a lot to remember there. Okay. These scalable products provide a real good hands-on learning of power systems with options of hardware like a second generator, for example, and software editions of for example, a SCADA system, which is supervisory control and data acquisition system. And materials is something that I do enjoy because we break things intentionally. This is a fundamental part of any engineering course. Okay, it's extremely comprehensive, looking at tension, compression, stress, strain, and also hardness testing as well, and structural experiments. This is a wide range. A lot of it is VDAS compatible as well. EC, or environmental control, this covers teaching equipment covering fundamental theories that you'd associate with thermodynamics, fluids, and heat transfer. So we're looking at cooling, refrigeration, air conditioning, and humidity. And thermodynamics, this is small scale equipment for experiments into the laws of thermodynamics, real life working systems, okay, with industrial components and assemblies. We've got engines, again, we have gas turbines that we can offer. Structures, this is one of our most popular ranges. We are market leaders in our structures experiments. They are modular experiments. We have static fundamentals, we have beams, we have stress, strain, buckling, arches, 2-pin arches, 3-pin arches, pin jointed. There are 18 or 19 or so different experiments. The hardware can be used as a standalone, or with the STR2000, you have the option of data acquisition, or like I said before, we can look at virtual experiments. Okay.
Now we've got exciting news coming on that later, probably I'm going to say autumn time frame. That's probably as much as I can give you, but there is news. There's exciting
there is news,
but I just can't say what it is because I want to build up your suspense.
Okay. We'll move on then.
And now VDAS, we've already talked about VDAS.
We know about VDAS now.
Go back through the webinar.
Yeah, we'll go to, there can't be much left now on the ranges. What about solar? We're not talking about the sun.
Yeah, come on, a day like today, we need a bit of solar.
I know, very topical. This range looks at teaching equipment for the core principles of solar energy. So we have photovoltaic cells in the middle. So we've got PV cells, the flat plate solar energy collector. We have focusing energy solar collectors. So students can learn about the efficiencies, but also the limitations of solar power.
Brilliant.
Okay.
It's not forgetting one of your favourites, apart from engines and
well, you know what, I always enjoy seeing this slide because it was back in the autumn in the States, in Auburn University in the deep South Alabama. This lab doubles up as a tornado shelter or a twister shelter. So inside of this shelter, we have 4 wind tunnels. You can see 3 subsonic wind tunnels there. And behind me in the lab, there was a AF300 supersonic intermittent wind tunnel. So if the students aren't escaping violent wind anomalies on the surface of the campus, they can hide in this room and have 4 wind tunnels circulating air in the lab. So it's a very, very exciting dynamic lab.
I think this picture is quite good at the moment because the wind tunnel right in front of us has got a frame mounted VDAS.
You're right. It has. Well spotted. Yeah.
Okay. Right.
Yeah, splendid.
is, I don't think we're quite done yet. We have got theory of machines, another one of your favourite topics. I think you've got about half topics.
Yeah, theory of machines. I think we covered that a few weeks ago. Going back a few weeks ago, my memory is not so what it was. But yeah, theory of machines. Even in that very picture, our equipment would satisfy everything that's happening in that gearbox. So you have a shaft, so you can have whirling of shafts. We definitely have vibrations in that gearbox. We can look at gears themselves with our gear apparatus. So a lot of real world applications in theory machines.
There you go, Dave. So that's
there you go.
Rounding it up all very nicely. Just remind everybody, as this is live, you do have the opportunity to ask your questions live to Dave before we wrap up in just a couple of minutes. Before we go, I mentioned the student competition earlier. This is an opportunity to engage your students on a different level. Also help achieve your communication learning goals as well. So we invite academics at universities and colleges around the world to work with TecQuipment. We'll sponsor a competition. We'll work with you on a set of predefined rules where you run a competition within your cohort. You could do this as part of your syllabus like Nottingham Trent University do, or you could do it as an extracurricular activity, like we were talking to some colleges and universities in America about doing soon. And this is where we task the students with the challenge of looking at a piece of theory, and you may want to hone that down, or you might want to keep it open depending on what your learning objectives are. But they need to look at the theory, then test that theory using TecQuipment apparatus, and then do the analysis of the results afterwards and make any recommendations and analyze how they might improve that as well. You can see lots of those videos I mentioned earlier in the student videos playlist on the TecQuipment YouTube channel. If you want to learn more about getting involved with that, we have a generic video that explains how this works on that channel as well. And do get in touch with me, Dion Knowles, the marketing manager at TecQuipment, and we can discuss how we might be able to move that forward with you. And the idea is that in the future, and we were going to do that this year, that the winners of the institution level competition would go through to an international kind of champions and champions competition, where each of the winners would go up against each other. And overall, we would have one global winner as a team there. So that's what will be coming up in the future. We've also got an interesting, if you haven't checked out our practical teaching and engineering education survey that we published last year, that looked at perceptions of practical teaching by academics and the role it plays in making students more employable, etc., then I'd encourage you to have a look at it. You can Google that survey and you'll find this infographic and the full report there. So that pretty much rounds us up with
No, it doesn't. No, it doesn't, Dion. No,
why not?
No, because I'm going to put you on the spot again. Now, we had a comment about a thick cylinder. Would it be possible for you to pull up a picture of a thick cylinder?
It most certainly would be. Let me go
because I would expect that some of the viewers want to know the difference in construction of the thin and thick cylinder. So let me just allow me a few more minutes of airtime, and I will just explain the main difference. There we go. So it's very, very similar. Okay, it's a very thick-walled aluminium cylinder. Now the difference is that cylinder is actually made of two halves. All right. Now in the middle, can you see a kind of a split in that cylinder? Okay, that's because before those two halves are put together, we actually bond strain gauges to the surface to one of the faces, okay, and its bore. Now these gauges are still measuring hoop, radial, and inner circumferential strains, all right, but the two halves are then bonded together after they are strain gauged, okay. So that's a very skillful job that we do in our factory. Then internal pressure is applied to the cylinder and they measure those strains. But the difference is that this is a very, very thick cylinder with a couple of inches thickness on its wall. That's the main difference. Okay.
Right. So extra strain gauges and
yeah, actually bonded to the surface of one of the halves, not on the surface of the cylinder itself, but actually, on one of the surfaces.
Right. So cut a piece of cake in half and sandwich it together.
Yeah.
And
Then we glue it together. Yeah.
Right. Okay. Because cake's very important, you see. I can deal with cake analogies.
Yeah. One more thing. Would you be able to pull up the VDAS screen of the SM1011, Dion?
Let's see. Now you're going to test me.
I'm making you work today. I'm telling you that now.
There we go. Look at this.
Sweating again. Mop Dion's weeping brow. It's coming.
There you go. It worked.
There we go. So that's one of the faces of the half of the cylinder, and that's the pattern of the strain gauges that is applied to one of the faces. So that's the difference. All right. So again,
another one just had 6 on the surface, and this has got another 10 embedded inside that sandwich.
Yeah, there's none on the surface. There's none on the actual surface of the cylinder. They are all inside.
Ah, okay, right.
Yeah.
Right.
Okay. I just thought I'd add that in, just in case there was anybody wondering how we construct the thick cylinder, the SM1011.
Brilliant. Good.
Okay.
Good. Well, that pretty much rounds us up for all of our content today on the on VDAS and the thin cylinder apparatus. I will remind us that next week we are back. And we are back throughout July, every Thursday at 1 p.m. British Standard Time. Next week's webinar is on physics, and we're focusing particularly on physics A level, but it will also be relevant for physics degrees at that entry level. And we are joined by Matrix as well. Matrix are another company in the industry, but they focus much more on the electronic side of things, whereas we focus on the mechanical thing. So together we've got Kyle Hatchard, TecQuipment's Kyle Hatchard, talking about the mechanical aspects of physics and practical teaching. And we've got Liam, who's from Matrix, who will be talking about the electronics aspects of physics as well. So if you're interested in that topic, look out for that. When it appears on YouTube, click the reminder bell so that you get a 30-minute notification that we are going live. You can go back and watch all of these webinars on demand. They are on a live playlist that we have. So we have all of those. We have engines, aero, fluid, environmental and solar. I'm not going to rattle them all off. You could go and have a look there yourselves. We've also got live events where we demonstrated the equipment last year in the factory, focusing on civil engineering, aerodynamics, and there was another one there, Dave, and I can't quite remember.
I can't remember, Dion. I'm sorry.
So thank you very much for joining us. Thank you for asking your questions, and we look forward to seeing you again next time. Thank you, Dave.
Thank you, everybody. Thanks then.
Thank you, everyone, and goodbye.